Okay, so section 1.2, this is all about symmetry, understanding how graphs work. Symmetry is a nice thing to understand when you're looking at a function. Is it symmetrical? Does it repeat? What kind of information can I get out of it? And being able to get the ideas about symmetry coming from an equation and going to the graph, or from the graph to get your equation. What does the equation have to look like based upon the graph? That kind of stuff. So there are three basic kinds of symmetry. And not every function has a symmetry. Not every equation has a symmetry. There are many that do not are asymmetric completely. So not everything fits in these categories, but these are the main categories you have. First, x-axis symmetry. If the point xy is on the graph, then the point x negative y is on the graph. X-axis symmetry are not functions. If an equation has x-axis symmetry, it fails the vertical line test because it has two y values for the same x value, which means it's not a function. And those y values happen to be opposite y values. If x is 1 for both 2 and -2, it has x-axis symmetry, and it is not a function. Okay. Y-axis symmetry, these are even functions. If f of x is on the graph, then negative xy, if xy is on the graph, then negative xy is on the graph. So if I change x from, let's say, +2 to -2, the same y value applies for both of those. So x and its opposite are both on the graph. That gives you y-axis symmetry. It's called even, and even and odd is kind of important. Polynomials, where the exponents are all even, all of them are even, that will have y-axis symmetry. That's why it's an even function. An even function, and other things other than polynomials can be even. But if you have a polynomial and all of the exponents are even, then it is an even function and it has y-axis symmetry. Think about x squared. Think about x to the fourth. We talked about those the other day. Those have y-axis symmetry. They are even. You take the paper, fold it on the y-axis, and the two sides match up perfectly. That's what happens with the parabola that's centered on the y-axis. Okay, anything that's centered on the y-axis and folded like that is even. Okay, and then if you have origin symmetry, it's called odd. It's odd symmetry. Polynomials with all odd powers have to fit in there, as do other ones. If xy is on the graph, then negative x, negative y is also on the graph. So if you have 2, 4 and -2, -4 on the graph, and it's true for all xy combinations, then it is odd. Let's see, sine. The sine of x is odd. The sine of 0 is 0. Yeah, it's an odd function. It has origin symmetry. Sine is odd. Cosine is even. Okay, cosine x, sine x, odd, even. Now you can change sine and cosine from odd to even if you add things or you do a shift. You can change that odd and even on those two things. Because remember, you can take a sine function and rewrite it as a cosine function. All you have to do is just do a shift. So you can change it both. Okay. So polynomials are the thing we're going to be concerned with most, but then other functions are also odd or even. But there are so many of them that are neither. Okay, so that actually happens. Most polynomials are neither. Nothing works for them. X cubed plus x squared, that's neither odd nor even, nor does it have x-axis symmetry. So, they can happen. Okay. Determine if the following equations have any symmetry. So we'll work through these together as an example of how you can do. That should do a little better. Is that okay? Is that readable for your young eyes? Because my old eyes are having issues, but I can do it. But I'm also right up close. So determine if any of the following have symmetry. So a couple of things you want to look at when you're doing a problem like this. I want to know, is it odd? Is it even? Does it have x-axis symmetry? And I want to test to see. I kind of want to take a look at it. If I have just y in there and then I have x squared, I'm thinking to myself, this is probably going to be even. This is probably an even one. All my powers are all even powers. So most likely this is going to be an even function. How do I test? Remember, when you have even functions, if I take x and replace it with the opposite of x, negative x, I still get the same thing. That would be an even function. So that's what I want to do. I take y equals negative x squared minus 4 over negative x squared plus 1. And I simplify that, and do I get the same one back again? Y equals negative x, and I square it, I get x squared minus 4 over x squared plus 1. I get the same thing again. Those are the same. I take x, replace it with negative x. I get the original y back. I get the same y for both of those. Then this one would be an even function. It is not a parabola. Okay? It is not a parabola, but it is an even function. Next one. Y squared equals x plus 3. So you want to be smart about this, because you're going to test for one of the three symmetries and see if it fits or not. And you want to shoot for one of them in particular. That's where you want to start. And if that doesn't work, you pick another one. So I look at this and I go, y squared equals x plus 3. Ooh, y squared. Y squared, what do y squared functions look like? When you graph y squared, what does it look like?
For every x value, it has to be y.
Yeah, but what does the graph look like? What's the picture of the graph?
It's like a hyperbola. It's sideways.
Yeah, it's sideways parabola. Is a sideways parabola gonna have symmetry around the y-axis? No, that ain't gonna work. It's not really gonna work around the origin. And around the origin, if you rotate it 180 degrees, you get the same thing that you had before. Visually, that's around the origin. Okay. More than likely, if I have a sideways parabola, it's gonna have x-axis symmetry, which means that I need to, okay, if xy is on the graph, then x negative y is on the graph. Take y, replace it with negative y, see if I get the same equation back again. And like I said, I look at the graph, ooh, it's got a parabola like that. It's probably going to be x-axis symmetry. So I take y, replace it with negative y, equals x plus 3. And then I simplify. Y squared equals x plus 3. I have the exact same thing with only replacing y with negative y. So yeah, this would be x-axis symmetry. Okay. Next one, y equals the cube root of x. So think about the graphs you did the other day. And you had that cube root graph. What did it look like? It looked like a cube kind of turned on its side. It went this way. If I take that graph and fold it up, is it going to line up? No. If I fold it up this way, is it going to line up? But if I rotate it like this, is it probably going to line up? Yeah. So more than likely, this is symmetric about the origin. more than likely. And this is why I was talking about having a visual of what the graphs look like for a function kind of gives you an idea of where you can go with stuff. It's leading me down the path that I want to try to go down. So I've got 3 choices. That function tells me I should go over here first and see if that takes me where I want to go. So that one would be odd if when I take xy and replace it with negative xy, and then I get the same thing back again. So I take xy, replace it with negative x, negative y. And do I get the same thing back again? So I have negative y equals the cube root of negative x. The cube root of negative x, I can pull something out of that. Because I can simplify cube roots just like I can simplify square roots, right? You want to simplify a square root, what do? You get a perfect square and whatever's left over, and then you take the square root of that perfect square. I can do that with cube roots. So I have negative y equals the cube root of negative 1, and that's a horrible cube root, I'm sorry, and the cube root of x, right? Because negative 1 times x is negative x, so I can split them up as well as I can put them together. Remember, all your rules go both directions. Almost everything goes both directions. So I can put them together, I can pull them apart again. What's the cube root of negative 1? Negative 1. So that means I have negative y equals negative cube root of x. Divide both sides by negative 1. Y equals the cube root of x. Look, I got the same thing back again. I replaced x with negative x and y with negative y. I replaced both of them. Got the same thing back again. That one's odd. Okay, the next one. This is a difficult one. This is a difficult one. If I replace x with negative x, if I do that, I only replace x with negative x and I don't do y, do I get the same thing back again? Well, if I take x to the fourth and put negative x in there, take it to the fourth power, I still get x to the fourth, right? But if I take negative x and put it in my denominator, if I take negative x to the fifth power, it does not make it positive x, right? So if I just put negative x in there, I get y equals negative x to the fourth plus 1, and 2 times negative x to the fifth, and that will not come out the same as the original problem. I'll get y equals x to the fourth plus 1. My numerator's good, but my denominator is negative 2x to the fifth. If I replace x with negative x, I don't get back the original problem. It is not symmetric around the x-axis. Didn't think it would be anyways. Pretty much the only ones that are so is where your y is squared or you have an even root. There are some other odd ones like that. So that doesn't work. Yeah.
Do like
So, excuse me for a minute. Okay, so I just screwed up everybody who was watching this. Okay, so I replaced x with negative x. Now I'm going to do it again. Now, if I replace y with negative y, but don't change x, to see if it is, and I have to check myself on this, to see if it's even, or sorry, to see if it's, sorry, that was the x-axis one, was that one. I did that one backwards. Did you see what I did backwards? Did I screw up? Did you see me screwing up? Did anybody go, what is he doing? He's got it wrong? Because I actually, that one was checking for even. And it's not even. That was my bad. That was my bad. And if you caught that and didn't say something, shame on you for not saying something to me. Because if I screw up and you think that I'm screwing up, say something. Because I might be. And I'd rather stop than go all the way through and have everybody completely confused.
So does it still not work?
It still does not work for even.
Wait, so is it not?
Not necessarily. So let's check. So it might be, it might not be. I'm eliminating things because this one's a good one. So I want to do the x-axis symmetry, which I thought I was doing and did wrong. Just replace y with negative y. Negative y equals x to the fourth plus 1, 2x to the fifth. Is that the same as I started with just replacing y with negative y?
Yeah. But when you check the y and the
No. I'm just checking for the x-axis symmetry, which you just changed the y on. So you change one, or change the other, or change both. First one I changed the x only, didn't work. This one I'm changing the y only, doesn't work. So this one is not x-axis. No bueno on that. Yes.
Basically, you start changing the x and y
So you figure out which one it is. Now, what if none of them work? Then it doesn't have any symmetry, which is perfectly fine too. And that may happen on your homework.
So, after you check, do you still do both?
Yeah. You have to check every one of them as you go along. Unless the first ones we only checked one, it worked. It will only work for one. It will not be symmetric more than one place, with a couple of exceptions. But you really don't have to deal with that too much. Okay? So this one here, I want to do it again, only I want to change both to negative x and negative y. So I put negative y equals negative x to the fourth plus 1 over 2 times negative x to the fifth. And simplify that. Okay, what is negative x to the fourth? It's the same as x to the fourth, right? So I have negative y equals x to the fourth plus 1 over negative 2x to the fifth. And if I multiply both sides by negative 1, right, times negative 1 times negative 1, this becomes positive, that becomes positive, and look what I did. So this one is symmetric. This one's odd. It is symmetric about the origin.
Wait, don't you have to do it to the top?
No. Good thing. Let's do a pause. Let's do a pause. No, and it's if you have something like this, where it's a rational function and you have different powers in your numerator and denominator, that you may be able to go by that. You may not. This is a strange one. If it's just a straight up polynomial and you have an odd power and an even power both in your polynomial, let's say you have x squared plus x, that's x to the second power and x to the first power, it's neither odd nor even. It has no symmetry. Okay? And that sometimes happens. This is an extremely odd one. This is an unusual problem. Normally, now, if I had x to the fourth plus x cubed plus 1, it would be neither. It would have no symmetry at all. This one only works because my numerator is even and my denominator is odd only because I have an even over an odd, the whole thing is odd. It's weird.
But if you had an x squared, it would still be even on the top.
If it had an x squared in there, yeah. Like I said, it's a weird one. It's a very weird one. And I do have a power here on the 1. I do have x to some power here on the 1. What is the power of x on my 1 on here on the end? 0. And 0 is even. So that is even because the numerator is even because every power of x is even, including the x that's non-existent because it's to the 0 power. Okay. But if I had another one in there, it wouldn't be either, it wouldn't work. Okay. Now, if I have an odd over an odd, then I have odd divided by odd is even. It would be an even one. But like I said, this is unusual. Rational functions are kind of goofy. Okay. And the goofy ones are where the interesting stuff happens. Right? If everything was all just straight lines and maybe parabolas, it would be extremely boring. It would be very easy, but it would be extremely boring. Okay. Questions on this? And it's strictly test by plugging in x or plugging in negative x, do you get the same thing? Plugging in negative y, do you get the same thing? Plug in both of them, do you get the same thing? And you don't necessarily have to, once you get one, you're done with the others. So maybe look at the problem before you decide what you're going to plug in there for your substitution, and maybe make your life a little easier by trying to guess the right one, and you only have to do it once instead of 3 times and land on the third one. Oh, only the third one. Now, complete the graph so it has the indicated symmetry. This is pretty easy. Even symmetry. That's about what's even symmetry? What is that? What is that about? Is it y-axis, x-axis, origin?
Y-axis.
Y-axis. So that means this is my center line. Both sides are mirrored. It's mirrored around the y-axis. So whatever I have on this side has to line up with the other side. Do I expect perfection? Yeah. No. I don't have particular values. I just want the look. Okay? If I want a perfect graph, you're going to use your calculator or a computer to give me a perfect graph. Well, it's a straight line. You can give you a pretty good straight line. But just about anything else, it's never going to be perfect. Straight lines are relatively easy to do. You can get a nice ruler, a nice sharp pencil. You can be very careful to give you a really, really good straight line. Anything else, not so much. Okay. Odd. What is odd symmetric about? About the origin. So the idea is if I rotate this 180 degrees, I get the same thing. So to complete it, I just have to imagine spinning this around. So if you want to stand up and look at it upside down, you'll see what I'm talking about. So it would look like that. And then the x-axis. So that's, if I flip it over, it's our image here. Now, a very interesting note about this particular one. When you, on the older graphing calculators, they could not graph a circle by typing in x squared plus y squared equals 4. That's a circle centered on the origin with a radius 2. They couldn't do it. Graphing calculators, early graphing calculators could not graph something unless it was a function. And a circle is not a function. A circle is an equation, but not a function. Okay, you couldn't do it. So what you used to have to do was graph the top half and then graph the bottom half. Top half of this one, y equals the square root of the radius squared minus x squared. Bottom half, y equals negative square root of the radius squared minus x squared. And you would have to type in both of those and have it graph one and then graph the other, and it gave you the top half and the bottom half. Now you can graph a circle as one, but you have to change it to a parametric equation, or not parametric, a conic section. And you have to tell your calculator it's not going to be y equals. Otherwise, it still won't do it. Yeah. They've come a long ways, but they're still got a ways to go. Questions? Okay, the last one actually is pretty easy considering that you did some graphing and stuff already. So it says check for symmetry. You can try to do this any way you want. I don't really care. So I look at x squared. What kind of symmetry is x squared going to have? It's going to have y-axis symmetry, which means that it's an even function. Okay. So this is even, has y-axis symmetry. As far as the making a table and graphing it goes, it really, I know my handwriting is horrible, get used to it. So you have to listen as I write it. As far as the graphing goes, honestly, plugging in a couple of points and creating a value to do this would be fine. By the same token, hey, you know what y equals x squared looks like, right? As far as I'm concerned right now, that's good enough. Okay. At some point, it won't be, and if we start getting into more complex things, I will be more clear with you where just a basic sketch isn't going to work. Okay. And if we move it off the origin, you should be able to figure out where the roots are, and then, oh, I cross this here and here, then it looks like this. Okay. Nice thing about parabolas, all parabolas are symmetric. They're not symmetric necessarily around the y-axis, but they are symmetric. They're symmetric around the axis of symmetry. Sometimes that happens to be the y-axis, sometimes it isn't. Okay, if you don't have an x in there, you just have x squared and whatever else it is. But otherwise, it's going to shift it over one way or the other. Okay. So, y equals x cubed. Remember what the cube looks like? Is this going to be odd or even? It's going to be odd. Which means that it is about the origin. And we got this disco thing going on. You do know what disco is, right? Y equals 1 over x. If I put in negative x, do I get the same thing? No. If I put in negative y, do I get the same thing? If I change both of them, do I get the same thing? Yeah, so this is symmetric about the origin. This would be odd, right? Yeah, this would be odd. Odd is symmetric about the origin. And if you look at the graph, it kind of makes sense. The graph looks like that. If I were to rotate this 180 degrees, what do I get? I get the same thing. So this one would be odd, which means it's symmetric about the origin. And the last one, that should be pretty easy to figure out. X equals y squared. What does that look like? It's a sideways parabola. Oh, crap. Oh, well. We'll see if I screwed up the recording or not. So it's a sideways parabola. Is it odd? Is it even? No, it's neither odd nor even, but it has x-axis symmetry. Questions? Cool. So those are the notes for today. You have the assignment for today. Go ahead and get to work. I'm here to answer any questions. I will know on Monday how many books I have. I will not have a full class set, but I imagine I will have enough for you guys to share. Because I got one more class to hand them out to.